In this video, I will be going over two named reactions, the Bischler-Napierowski and the Pictet-Spengler reaction. I will go over their basic conditions, the reagents, and the mechanisms, and then do a comparison of both of them, and then a name the reaction literature example to distinguish between the two similar reactions. So for the Bischler-Napierowski synthesis, it is an example of a Friedel-Crafts acylation, which is also a type of EAS, and it's for the synthesis of isoquinolones, and I included a drawing of one here. The reagents for this reaction are very specific and part of the identifying of the reaction. So it includes POCl3, which will be used in the mechanism, P2O5, PPA, TFA, or TF2O. Okay, so this is the Bischler-Napierowski reaction overview. So we have the starting materials on the left, and so this is like the most standard form that this reaction can take. And then our reagent in this case is POCl3, which I drew out because that will be important in the next steps of the mechanism. And then this is our isoquinolone product on the right. Okay, so for the mechanism for the Bischler-Napierowski, we have our starting material and our POCl3 reagent. The first arrow is going to be from the lone pair on the oxygen attacking the phosphorus of the POCl3. And the second arrow shows the double bond being pushed up onto the oxygen as a lone pair. Our next move will be to show the resonance forms of this. So the next arrow will be from the lone pair on the nitrogen to form a double bond, and then pushing the double bond from the oxygen to form another lone pair. And then for our next step, we can reform the double bond on the other oxygen and use that to kick off a Cl. Okay, so we are now going to redraw the result a little bit more suggestively, and then we're going to use the double bond from the benzene to attack the other double bond and push the electrons onto the positively charged nitrogen, which will form our ring. So then here is our ring structure, and we want to restore the aromaticity to the benzene ring, so add all three double bonds back. So we are going to use a base to deprotonate that hydrogen and reform the double bond. And then our last step is going to be deprotonating again, and we're going to use that to form the double bond to the nitrogen and kick off the O-POCl2 group, which will leave us with our product. So for an overview of the Pictet-Spengler reaction, it involves substituted beta-aryl ethylamines, and it is especially successful with electron donating substituents, and it's for the synthesis of a tetrahydroisoquinoline, which is shown here. So it's similar to the last product, but it's a little different, as you'll see. And the reagents for this one are very broad, and there's less guidelines for it. So you need a carbonyl containing compound, which is often an aldehyde or a ketone, and an acid, which can be protic or a Lewis acid. Okay, so here's our Pictet-Spengler reaction overview. So we have our two starting materials, and we have an acid as the reagent. So this lists HCl as like an example acid, but it can be almost anything. And then here is our tetrahydroisoquinoline product. Okay, so this is going to be the mechanism for the Pictet-Spengler reaction. So we're going to start by drawing the carbonyl, and because we are an acid, our first step is going to be protonating the carbonyl. So then we are going to add the other starting material together by drawing an arrow from the lone pair on the nitrogen to the carbonyl, and then we're going to push the electrons from the double bond onto the oxygen. So this is the result from doing that, and we are going to use the conjugate base to deprotonate a hydrogen and remove the plus charge from the nitrogen. And then our next step will be protonating the OH to form H2O, which is water. Okay, so our next step is going to be to use the lone pair on the nitrogen to form a double bond, which will then kick off the water that we just formed. Then, in a similar step to the previous mechanism, we will use the double bond from the benzene ring to attack the other double bond and push those electrons onto the nitrogen to form our second ring. Our final step will be deprotonating the hydrogen to restore the aromaticity again and reform that double bond, which will result in our product. Okay, so for a quick recap and an overview of the comparisons, both involve amine chemistry, which means they're both nitrogen containing, but they have different starting products and results. So the product of the Bischler-Napier-Alski is an isoquinoline, which is on the left, and for the Pictet-Spengler, it is a tetrahydroquinoline. So they both look very similar, but there are differences to note. For the Bischler-Napier-Alski, it has very, very specific reagents, and as you most often will see is POCl3, and Pictet-Spengler has more varied reactions and will just involve a carbonyl and an acid. So you can look for these things and use these tips in the next section. Okay, so now that both reactions have been identified, it's time to put that knowledge to the test. Here's a literature reaction. Using the previously provided information, I will give you a few seconds to figure out what type of reaction it is. If you guessed Bischler-Napier-Alski, you would be correct. So the biggest clue is the POCl3 as the reagent, but you could also identify the starting materials as being similar to what we showed, and the product as being an isoquinoline.